Okay, so when you're factoring trinomials, it is a little bit different than a binomial or a perfect square. So you're trying to find two numbers that multiply to your last number but add to your middle number, just to make it very straightforward. Okay, so what we really want to look at is our last number, and that's when there is no coefficient. So like m squared doesn't have a number in front of it, but for 16 and 17 it does. So then that'll be a little bit different. Okay, but just to talk about 15, what are two numbers that multiply to negative 30 but add to negative 13? Okay, so the easiest way to do this is to break down 30 into two numbers that multiply to it, which, you know, could be 5 and 6, but I can't get 13 out of that. 10 and 3 will give me 13. Okay, there's also 15 and 2. That could somehow give me 13. Okay, so I need a negative 30 and a negative 13. Alright, so if I have negative 10 minus 3, is that going to multiply to a negative 30? No, that would give me a positive 30. Okay, so those are out. That's the only way I could get 13. So what if I did 15 and 2? Their difference is 13, and I want a negative 13. So negative 15 plus 2 will give me 13. Negative 13, excuse me. Negative 15 plus 2 will give me negative 13, and when I times them, it'll give me negative 30. Okay, so that's how you're going to factor here. And so this would just be m plus 2, m minus 15. Okay? And that's like when your coefficient is 1 in front of the leading variable there. So m squared has a coefficient of 1. That makes it a lot easier. Okay? So let's talk about 17. Because you can see d squared has a coefficient of 2. So that makes it a little bit harder. That's when you have to factor by grouping. Okay, so 2 times negative 7 is negative 14. And now you want numbers that will give you a negative 13 when you add them. So it's obviously going to be 14 and 1. And I want a negative 13, so that would be a positive 1 and negative 14. Okay, and the hard part is that I can't just say d plus 1, d minus 14, because the 2 is with the d squared. So I'm going to teach you factoring by grouping, or I'm going to assume that's what you were taught, okay? If this goes over your head, you need to star 17, and I will show you a little bit of an easier way, which is how I personally factor. However, I believe most of you were probably taught the way I'm going to do it. Okay, so you split the middle into plus 1d, or you can just have plus d, and minus 14d. Okay, and then you bring everything else down. So we still have the 2d squared, and we still have the minus 7. Okay? Then you think of them as like two separate groups, and you take out what's in common. Okay, so 2d squared plus 1d, what's in common is d, and that would, if I factor that out, it would give me 2d plus 1. Okay, now remember, if they're both negative, what's in common has to be negative, and 7. Alright, and what's left is 2d plus 1. Okay, and notice one of your factors should be the same. So you write that once, and then you put the other numbers in front to make it blunt, so you know what I'm talking about. You put those together to make your second factor, okay? So we have 2d plus 1 times d minus 7. That's how you do 17. Okay? So, I'm going to skip around here and just talk about, let's do 18 and 20. Okay, so 18, the coefficient in front of your highest exponent is 1. So we can kind of do this the faster way. So we're going to break up negative 20. And let's see, we want to get negative 1 for the coefficient in the middle. Okay, so 4 and 5, their difference is 1. And I want to get a negative 1, so that would be positive 4 minus 5. Okay, so what you don't want to do though is x plus 4, x minus 5. Because we have an x to the 4th. Okay? So if you were to break that up into two different binomials, it would have to be x squared. Okay? Or think of square rooting it, because you're splitting them into two things multiplied together. Alright, so this would factor to x squared plus 4, x squared minus 5. Okay? And you obviously can have those binomials flipped around, because when you double distribute, you're going to get the same thing anyway. Alright, in 2020, we don't have a coefficient of 1 in front of the g squared. It's 10. So we're going to have to take 10 times 9, 90, and figure out numbers that could multiply to 90 but add to negative 21. Okay? And if you're super stuck, then write them out. I know 90 is 1 times 90, 2 times 45, 3 times 30, 5 times, let's see, 90 divided by 5 is 18, so we have 5 and 18. Okay, and just see if any of them could possibly give you 21. 6 and 15. Okay, so 6 and 15, if I add those up, I could get 21. So let's see if that will work. I want a positive 90, but a negative 21. So negative 6 minus 15, add to 90, or excuse me, add to negative 21 and times to 90. So those are my winners there, if that's how you want to think of it. Okay? So we have to split the middle here, negative 21, into negative 6g and negative 15g. Okay, and you could definitely write those the opposite order, and we still would get the same answer, okay? So then, group them up. First two and your last two. Alright, so what's in common with 10 and 6? Is a 2, and what's in common with g squared and g is g. Alright, what's left is 5g minus 3. Okay, let me just erase this real quick. Alright, and then if you have a negative, you always have to take that out front. So negative 3 is what's in common with 15 and 9. And what's left is 5g minus 3. Okay? So one factor should repeat. You write it once. And then the outsides go together for your other factor. Okay? And that's number 20. Alright, so factoring by grouping, since we've been doing that above, let's just do 23 and 24. Okay? So when you have 4 terms, the only way to really factor is by grouping. So you're going to group up the first two, group up the last two, find what's in common, and if they don't have a common factor, like 5g minus 3 repeated here, if they don't have that, then chances are it's non-factorable. But if they do, then it's definitely factorable. Okay? So let's look at 6r cubed minus 9r squared. What's in common is definitely r squared and 3. So 3r squared, and let's write what's left. So like I said before, you're technically dividing. You're dividing here to figure out what's left. So 6r to the third divided by 3r squared is just 2r. Then minus 3. Okay, and what's in common with 10 and 15? They don't have r's in common, so just looking at the numbers is 5, positive 5. So that'd be 2r minus 3. Okay, and since we do have a repeated factor, we can put the outsides together for one factor and then write the repeated. Okay, so it doesn't matter, you could have these two switched up as long as they're the same on the inside. Okay, and that's factoring by grouping. Alright, let's do 24. So same idea, we're going to group the first two, group the second two, find what's in common, and hopefully they have a repeating factor or it doesn't factor. Okay, so what's in common with 4c to the third plus 20c squared is 4c. What's left? 4c squared. What's left is c plus 5. Okay, then 9c and 45, what's in common is 9. And it's a positive 9, so put the plus. Then we have c plus 5. Okay, so these both repeat. So we'll have 4c squared plus 9 times c plus 5. Okay, and you could have those binomials reversed. Same correct answer. Okay, so the rest is just a mix of all different kinds of factoring, and I'm probably going to pick a few for your warm-up, so we're just going to skip that because it's a mix of